All right, guys, are there any questions over the previous assignments before we get started? That's fine. Everyone does need a graphing calculator. You need to make sure to grab one.
Just kick my only able way to walk to my classes.
So, a quadratic in one variable, pretty much what we've been doing. Solving them, there's different ways we can do them. The first three ways that we're going to go over or have are these here. Now, out of these three ways to solve quadratic equation, we've done one of them so far, and that's solving it by factoring. We did that in 3-1-3. Now, there are two other ways to solve quadratic equations. One of them is graphing, and the other is using the square root method. So we will see more solving by factoring in this here, but we're also going to be looking at graphing and using the square root method. Now, to solve an equation by graphing, we need to see what value of x will make the equation be 0. Because for every value of x that will make the equation be 0 will be a solution. And the place where it is equal to 0 is what we call the x-intercepts. It's the points on the graph that cross the x-axis. And there could be 1, 2, or 0 solutions, depending on how it intercepts the x-axis. Now, normally we would do this in several different ways. We would go about finding the vertex, then 2 points to either side of the vertex to get the graph and go from there. But one of the nice things with the technology that we have is we have this graphing calculator. Well, let's clear all that out. Clear. So the first thing you need to do is turn the thing on. You need to turn the graphing calculator on. On. That's fine. Hit clear. It'll still work for a while. So have you pay attention to this. You're good. Now the first thing we want to do to type or to graph this is hit y equals. First thing we need to do is hit y equals because we need to type the function in. Y equals up at the very top.
Mine looks like
Yeah, someone typed in all those. If there's anything typed into any of them, we need to clear them all out because sometimes other students type a bunch of stuff in there. Now, also, I don't think any of y'all have it, but if plot 1, 2, or 3 was turned on, I'm going to turn this on. Don't turn it on. If it's kind of bolden like this here, we have to turn it off. It will mess things up. So if one of them was highlighted, I don't think any of y'all's are. I can use the arrow key to go up, select it, hit enter, and it'll turn it off. So one way you know that they're turned off is that plot 1, 2, and 3 are all in dark print, not white print with a dark background. Okay? Now the first equation that we had, the first one we're solving for, is x squared minus x minus 6. And to graph quadratic equations, or to graph any equation when we're solving, we need it equal to 0. This one is, so we're good there. So now we just need to type it in. So we'll type it in as x. So right next to alpha, we can do x squared. Minus x, I believe it was plus 6, yes? Any question? Minus 6. Yes, that would not work. Plus 6, minus 6. Questions on any of these buttons? minus x minus,
There was none in there.
because we'll use this for all the x's. Questions on any of this here? Minus, so we do x. So we do the button that you got x the first time. So we do it again. We got x, yep, minus 6. So we're looking for the x-intercept. So was everybody able to get this typed in? So now we're solving by graphing. We need to graph this, yes? So the next button we're going to push after we get this all typed in is the button labeled graph. And what that tells the calculator to do is to graph this function. So we have this graph here, and again, when we graph it, what we're looking for is what value of x will make the function be 0. What value of x will make the function equal 0? And we can see here, there are 2 places where it does occur, because it equals 0 when the y value is 0, when it crosses the x-axis. And there are 2 places where this does indeed cross the x-axis. Now, what we can do next is you can do second, the blue button, graph. Second graph. And it pulls up a table. And again, we're still trying to find out what value of x will make the function equal 0. What value of x will make the y value be 0? And indeed, one of them is -2, because when x is -2, the y value is 0. And the other is 3. So the solution for this is x is equal to -2 and x is equal to 3. We'll do another one, yeah. Now if we check this, I can plug -2 back in for x. Because if I want to check -2, we plug it back in for x. We replace every x with -2. And if this is indeed a solution, it should equal 0. Well, -2 squared is 4, +4. -2 is +2 minus 6. Well, 4 plus 2 is 6. And 6 minus 6 is indeed 0. It does work. We can do the same thing with 3. We can say 3 squared minus 3 plus 6, not plus 6. 3 squared minus 3 minus 6 equals 0. Well, 3 squared is 9. -3 minus 6, which gives us 9 minus 9, which again is 0, like we expected. Questions on this here? Are you ready for the next one?
So the x will equal 2.
So x on the last one was -2 and 3. -2 and 3. Let's look at the next one here. -2x squared minus 2 equals 4x. Yes. For us to be able to graph these, we need it equal to 0. For us to be able to solve these by graphing or factoring, either one, we need these equal to 0. So we're going to subtract 4x from both sides because we need this equal to 0. Questions on this so far? Now when we subtract 4x from both sides, our 4x minus 4x would give us 0. On the left-hand side, the 4x, -2x squared and -2, none of those are like terms, so we just put them in order. So we have -2x squared minus 4x minus 2 equals 0. Now, when we were graphing these, we did some of them solving by graphing. We really wanted the number in front of x squared to be positive, so we would divide out a negative. Here, especially the graphing calculator, it does not care if the number in front of x squared is positive or negative. It can be either one. So we can grab the graphing calculator to graph this. Again, first thing we need to do to type the function in, we're going to hit y equals. It sometimes might be helpful to hit clear to clear the previous function out so we can type the new one in. So our first thing is negative 2x squared. Whichever number goes first, if it's negative, we have to use the negative. We cannot use the minus. But our next one is minus 4x minus 2. If you do put a minus in front of the 2x, the calculator will let you know. It'll throw a little bit of a fit, but it will tell you. I will show you here. So if I put minus instead of negative, I hit enter. Well, apparently it's going to let it work. Some of the times it will. Yep, there it is. It does not like it. And the reason it doesn't like it is because it does recognize that as a minus sign. It's expecting for there to be a number or something in front of it. Something to subtract it from the 2x squared. Now we do have two options. You have quit and we have go to. Yeah, go to. And this is helpful because if you're not sure where the error is at, select go to. It put the cursor right where it identified the error at. So it kind of helps you figure out if there's a problem somewhere in what you typed, select go to and it'll take it to where it believes the error is. We fixed it and now we graphed. So did it intersect the x-axis? Yes. Where did it intersect at? -1. Now if we want to make sure, again, we can go second graph to bring up the table. And when x is -1, the y value is 0. So it tells us the solution for this is x is -1. We'll get more into this, especially in later chapters. There's always going to be two solutions. For any quadratic, there's always going to be two. And I said previously, there's not always going to be two unique solutions. On some of them, like this here, we get the same solution twice. One of the big giveaways that we have the same solution twice is that the graph hits the x-axis, it touches the x-axis, but does not cross it. It doesn't go through the x-axis. And I'll look back at the graph here. If we look at this here, it doesn't actually cross the x-axis. It touches it at -1, but does not cross it. And when we get into especially chapter 4, higher degree polynomial functions, this is called an even multiplicity. It has an even number of solutions at that point. Any point on a graph for polynomials that touches the graph but doesn't cross has an even multiplicity. There's an even number of zeros there. So it could be 2, 4, 6, 8 going on. But with quadratics, we only have two. We can only have two solutions. So it only appears twice. Questions on this here? For most of graphing, yeah. X squared minus 8x plus 12. Is it already equal to 0? So in the graphing calculator, we can hit y equals. We can clear that out. Do x squared. Already lost the rest of the equation. Minus 8x plus 12. Graph. Do we have 2? 1, 6. Because we can sometimes see it from the graph itself. because we can count over, not 1 and 6, it's second table, 2 and 6. And again, when we're looking for solutions, we're looking for what value of x will make the y value be 0. 2 and 6. Now we do see that the x value when x is 0, y is 12. That is the y-intercept. For solving, that doesn't actually tell us much. We're looking for the x-intercept. So 2 and 6. So here we can say x is equal to 2 and x is equal to 6. Questions on this here? Any questions on any of this so far? And I believe I mentioned this in class before. Factoring works well, but not everything's going to factor. Graphing works well, but not everything will be graphable. And that seems odd, but let's look at this here. Now this equation, to be able to graph it, we need it equal to 0. So we need to move the x squared. So I can subtract 1/2 x squared from both sides. 1/2 x squared minus 1/2 x squared is 0. Equals negative 1/2 x squared. Plus 6x minus 20. So we get this here. Now we haven't factored any with a 1/2 so far. As if we were, we'd have to simplify that out. And luckily simplifying that 1/2 would not be difficult because I can multiply it by 2. Because 2 times 1/2 would be 1. Then I would multiply the rest of the function by 2. And it would reduce our fractions. But the graphing calculator doesn't care. It'll take it in decimal, fractional, any form. Clear. Fraction alpha, y equals, enter. Alpha, y equals, enter. And we get this here. Now it was negative 1/2 x squared plus 6x minus 20. Negative 1/2 x squared plus 6x minus 20. And the next thing we would do is hit graph. And it crosses the x-axis at 2 places, which are nowhere. Does it cross the x-axis? So can we solve this by graphing? No, because not every graph will cross the x-axis. So what do we say? This has almost no I can spell solution. No real S-O-U. I don't know why I keep trying to spell sol. S-U-T solutions. It has no real solutions. So there are solutions to it. They are just not real solutions. We touched a little bit on this in chapter 1 when we talked about number types, real numbers, how I said there was something other than real numbers. We will get to those. So there are solutions to this function. There are values of x that do make this function equal 0. They're just not real numbers. And we'll get to those later. Questions on this here? So if you do have one that you graph and it doesn't cross the x-axis, they're just not real solutions. So, okay. So graphing works as long as it crosses the x-axis, yes? If it doesn't, then there's no real solutions, and we're going to have to find another way to find that one. But let's look at this one here. 4x squared minus 12x plus 9. Let's graph it. So we'd say 4x squared plus 12x, what is it, 12? Make sure, minus 12x plus 9. Questions on how we type this in? Questions on any of this so far? So we type this in and hit graph, yes? Yes. Most likely someone has gone up or down too far. So if they're really, are they big negatives or big positives? So you're going to need to scroll up. Yeah, I think someone just held the down button to get really big. Do Zoom.
Yeah, we've tried it.
6. So if the graph doesn't show up kind of nicely, Zoom square or standard is what you're looking for. Because if the graph looks a little weird, I would go Zoom standard. What that's telling the graph to do is on the x-axis, show it from negative 10 to 10 on the x, negative 10 to 10 on the y, and go by ones. So it'll get back there. Now, Zoom trig is for trigonometric functions. I've not messed with Zoom integers or Zoom stat. Zoom fit, if you get really big numbers and it's not showing up at all, you can tell it to do this and it's going to approximate the scale so you can see the graph. It normally throws things a little bit out of whack. But if we look at this here, we can see that it does cross or hits the x-axis somewhere between 1 and 2, yes? And if we look at the table, does it give us a value? Well, no, we don't have a y value that is 0. There is a solution, it's just fractional.
So it's no solution.
There is a solution, we just can't necessarily find it by graphing. It is possible, but to do that, we would start having to mess with the window or the scale. Because we could say the table's set to go by a half. And if I look at the table, 1/2 is there. But I'm going to reset the table set to 1. Right here. It is 1/2. So graphing didn't immediately give this to us. There are some ways to get it, but we could also then, we could solve it by factoring. Because when we look back at this, 2 sets of parentheses with 3 spaces because there is no greatest common factor. Since the third term is positive, our signs are the same and match the sign of the middle term, which would be negative and negative. Factors of the first term, 4x squared. Well, we would have x and x. Now, factors of 4 are 1 and 4, or which one do we want to try? 2 and 2. Factors of 9 are 1 and 9, or 3 and 3. Let's do 3 and 3. And if we check this here off to the side, 2x times negative 3 is negative 6x. Negative 3 times 2x is negative 6x, which does indeed give us negative 12x. Is that the middle term we wanted? Mm-hmm. So this tells us that 2x minus 3 is equal to 0, and 2x minus 3 is equal to 0. Now we do need to solve. because we did this on 313, where we had to break it 2 sets of parentheses. Our zero product property states that any two things multiplied together to equal 0 means one of them must be 0. So the first thing we can do is add 3 to both sides, telling us 2x equals 3. Lastly, divide by 2. So 3 seconds, 3 halves, which is indeed 1.5. So we get that there. Now we technically do have a second equation. Same thing, so we would add 3 to both sides, telling us that 2x equals 3. Divide both sides by 2, telling us x is also 3 halves. So the problem that we had earlier, I believe it said x is equal to -1. It only showed up once. That's why it showed up twice. Same thing here. We still have 2 solutions. They're just not unique solutions. Now, the part of the reason I showed y'all this one and the last one is to say factoring does work in most cases, and especially when our solutions are rational, they're fractional. It still works. Graphing is a little bit harder to see. Luckily for this here, the fact that it was 1.5 was a little bit easier to see. But it also being 2/3 would be just as close to it, but that's not as easily to see or pick out. Factoring will work well when it's rational, or not, or just integer solutions. Graphing works well when it's integer solutions. But graphing does not work well when it doesn't cross the x-axis. It has no real solutions. Factoring will also not solve when it has no real solutions. So there's going to be some pluses to graphing, because graphing, if we can graph it and find the solutions easy, it makes solving a lot easier. If they're not integers, we're going to have to factor. Questions on any of this here? Questions on anything we've done so far today? We're going to start the next part. So we feel pretty comfortable with graphing so far. So we've gone over factoring. We've gone over graphing, because we went over factoring in 313. We've gone over graphing today. And the other method that we're going to do today, we're going to finish this possibly tomorrow, is the square root method. The square root method works if there is no middle term and there's only one thing being squared. It could either be written as x squared or a set of parentheses squared. We do not have a variable to the first power outside of being squared or instead of a side of a parentheses being squared. And if we use the square root method, so there is no x to the first power, the first thing we want to do is get the term being squared by itself. Get the term being squared by itself. So if we're looking at this here, the x squared is the term being squared, yes? To get it by itself, what would we need to do first? Yes, we would add 31 to both sides. And if we add 31 to both sides, the negative 31 plus 31 would be 0. So it tells 4x squared is equal to 80. Because 49 plus 31 would be 80. Is our x squared by itself. So we need to divide both sides by 4. So we're going to divide both sides by 4. x squared is equal to 20. Step 2, take the square root of both sides. Take the square root of both sides. Once we get that term being squared, either as a set of parentheses squared or x squared, we're going to take the square root of both sides. And when we take the square root of both sides, well, the square root of x squared would be what? X is equal to plus or minus. Because whenever we take the square root of both sides, we have to include the plus or minus. Because whenever we square a number, because if we have 2 squared is 4. Negative 2 squared is also 4. Now we do need to figure out what the square root of 20 is. Fortunately, I didn't turn on the TI-30XS yet. We can turn it on. And I can say second square root of 20, which is 2 squared of 5. There's a lot of things, especially with radicals, that the yellow calculator, the 30XS, will do better than the graphing calculator. If we type this into the graphing calculator, think what it gives it to us as a decimal approximation. I don't want the decimal approximation. I just want simplest radical form, which is 2 square root of 5. And that's it. Now there is a third step, technically, which is solve for x, solve for y, solve for the variable. But once we took the square root of both sides, what's the variable by itself? Yeah, we already solved for it. Now in some cases we could end up, after taking the square root of both sides, that x minus 2 equals plus or minus the square root of, or 2 squared roots of 5. Then we would need to get x by itself. But here, x is already by itself, and we're finished. Questions on this here? Now, if I did get this equal to 0, I'm not going to go through the full steps of getting it there, because we had just subtracted 49 from both sides, telling us that we have 4x squared minus 80. Now, the reason I do this is to type it in, 4x squared minus 80 graph. It does cross the x-axis at 2 points, yes? Are either one of those points an integer, or one of our nice numbers? Well, no. Because one of them is 2 square roots of 5, the other is negative 2 square roots of 5. Square root of 5 is an irrational number. It's a non-repeating, non-terminating decimal. So it's not something that will easily show up on the table. We would have to actually go look for it. Now, for those of you who are taking the ACT Thursday, because I think some of y'all are, there is a way to find it. I will show you this here. Second trace. And this is a way to make sure to especially check, because we know what one of them is. It's 2 square roots of 5, yes? If you notice, the first one in that list is what? Value, yes? Hit enter, because it's already there. Value. What this is having the calculator do is calculate a value. As long as it is between negative and 10 and 10 on the standard function, it'll do this. Because we said one of the solutions for this was 2 square roots of 5, yes? I'm going to plug it in and hit enter. So the calculator is going to take 2 square roots of 5, plug it back into the function, and tell me what the y value is. Tell me what it equals. And here it equals 0. So it is telling me that 2 square roots of 5 is a solution, because it does give us a y value of 0. But to use this, I had to know what the x value was. I could do it again and say negative 2 second square root of 5 enter, tells me it's also 0. It is a way to check it, especially if they give you a quadratic function you're having trouble finding. The nice thing with the ACT, it does give you answers. So I could type the function in and try plugging the answers in. Or I could just plug the answers in for x and try it also. We will stop here for today. We will finish these note sheets at a later date.